Hi everyone, Ravi this side. Welcome to EnggAdda. Today in this video, we are going to discuss about one of the LeetCode question, which is question number 697, and it says degree of an array. So we have to find out the degree of an array. It is a question number 697. So let me try to go to the LeetCode and go to the particular question, and then we'll try to discuss what the question is asking and then how we can develop the solution for it. So let's get started for that, and let me try to come out of it and go to the LeetCode here. So here you can see I am in the question number 697, degree of an array. What you can do, you can go to the LeetCode array section and then you can find out this question number 697. So let me try to go there. So here you can see you can go to this tag array and then you will find all the question related to the array. If you'll scroll down, you will find that question. So let me try to go down. It is 697 degree of an array. It is under the EG section of the array. So this is a question. Now what I'm going to do is I'm going to explain the question for you and then we'll try to develop the solution for it. So the question says degree of an array. Okay. Given a non-empty array of non-negative integers. So there is an array of non-negative integer and the array is also non-empty. So there is an element in the array and those elements are non-negative. The degree of this array is defined as the maximum frequency of any one of its element. Okay. So the degree is nothing but it is the maximum frequency of any one of its element. So let's say it has 7 or 6 elements and one element is repeated 3 times. While others are repeated 1 or 2 times, then the degree of this array would be 3. That is what it is saying. The degree of this array is defined as the maximum frequency of any one of its element. Your task is to find out the smallest possible length of a contiguous subarray of nums that has the same degree as nums. Okay, so the degree is now clear that we have n number of elements inside an array and the element which is repeated most of the time is what the degree of the array. Now what is the real question is we have to find out a subarray which has the same degree in it. Okay, so your task is to find out the smallest possible length of a contiguous subarray of nums that has the same degree as nums. So you can see we have to find out the subarray which has the same degree in it, and the another condition is the smallest possible length of a contiguous subarray. So the length of that subarray would also be smallest and the degree is also preserved. So this is what the question is. So here you can see for the example first you can see that we have 5 elements 1, 2, 2, 3 and 1, and you can see the degree of this would be 2 because the element 1 and element 2 is repeated 2 times. So it has 2 elements that has the count as 2 and the degree is also 2 for this array. But now for the solution what we have to find out is we have to find out the smallest possible length of a contiguous subarray. So we have to find out a subarray which has the smallest possible length and its degree is also 2. So you can see that the input array has a degree of 2 because both elements 1 and 2 appears twice of the subarray that has the same degree. So you can see that these are the subarrays possible from this given array which has the degree 2. Okay. And if you'll find the smallest possible subarray which has degree 2 is 2 and 2. Okay. So that is what the answer is. So we have to return the shortest length. Like we have to return the length of that smallest subarray which has the same degree. So the length would be 2. Okay, that is what we have to find out. So let me try to show you this thing again from the different perspectives. So you can see that we have this element, we have this array which has 2 elements with the degree 2, and so the degree of this array is 2. Now we have to find out the smallest possible subarray that has the same degree. So you can see you can take this array as well where it has 1, 2 times and 2 times, and the degree would be 2 again. You can also take this one which has the degree as 2 because 2 is coming twice. Again, this can also be the possible solution. This is also one of the solution. This is also one of the solution, and this is also one of the solution. So we have to find out the minimum one, the smallest possible length. Now you can see that how we can find it out. So we have to find out, first thing is we have to find out the element which has the most count. That will define the degree. And then we have to find out the difference between the first index of that element and the last index of that element. And whichever is the smallest, we have to return that as a length. So you can see that here for this array, you can see the 1 and 2 are the element which count has 2. So the degree of this array is 2, and there are 2 elements which has the same count. Now if you find out the difference between the one first index and one last index, you will find out it is 0, 1, 2, 3 and 4. So it would be 4. And if you find out the difference of this 2 which has the same count as 1, and also it defines the degree of this array as well. So if you find out the difference between these 2, it will be like 1 and 2, that means it would be 1. But the length would be, we have to include this both of them, so the length would be 2. And here the length would be 5. Right, so that is what we have to find out. We have to find out the element which has the maximum count. If there are 2 or 3 elements which has the maximum count, then what we have to find out? We have to find out the difference between the first index and the last index of that particular element, and whichever is the minimum one, we have to keep in mind that that is the subarray, and the length of that would be the difference between the last index of that particular element to the first index of it plus 1, and that we have to return. So this is what we are going to do here. So if you go to the example 2, you can see that we have around 7 elements like 1, 2, 2, 3, 1, 4, 2. So you can see that the degree of this would be 3 because we have one element which count is 3. You can see 2 as the count 3. So the degree of this element would be 3. Now we have to find out the subarray which has the same degree and its length is also minimum. So you can see that we are going to include this as a subarray, which is 2, 2, 3, 1, 4, 2, and its length is 6 here. Okay, now if you pick the first element 2 which has the index 1 and the last element 2 which has the index 6, and if you find out the difference between them, it will be 5, and if you add 1, then it would be 6, and that is what the length of this subarray is. So that is what we have to return out. So this is what we are going to develop here, and this is about the problem, and now we are going to do the solution here. So what we are going to do is, now let's discuss the solution. What we are going to do for this problem is, so you can see we have this array. Now what we are going to do is, first we are going to convert this array into the list, and then we are also going to create a map out of this array which has the key value pairs, and the key would be the element and the value of that element would be the count of it inside this array. So we are going to create a count map which has the count of each element, and then what we are going to do is we are going to create a new array where we'll try to keep those elements which has the maximum count. Let's say here in this example we have 1 which has count 2 and 2 which has count 2. So we'll try to keep those elements inside that new array which has the same count. And now we'll try to find out the difference between their first index and the last index, and whichever is the minimum, we'll try to add 1 and then return it out. That is what we are going to develop here. So let me try to go to this solution and then try start developing the solution here. So the first thing is I'm going to convert this array into the list. So int I equal to 0. You can use array.toList, but let me try to iterate through it. Dot length y plus plus, and then I'm going to create a list. Let's say it is a list of integer L equal to new array list. Okay, so we are going to add one element, or one by one you can say each element from this array inside the list, and we have all the elements inside the list. So we have the list ready. Now what we are going to do is we are going to create a map here, and that will contain the count of each element from this array. So let me try to create a map here, map of integer. Okay, so we have the map now. We try to keep it above. So we created a map. Now what we are going to do is we are going to iterate through the array, and we are going to find out each element count here. So I equal to 0, I is less than nums dot length, and I plus plus. Now what we have map. We are going to find out if this element already exists in the map or not. So for that we have this contains key. If contains this key, which is nums i, in that case what we have to do is we have to find out, like map dot put, what we have to put inside the map is nums i, and then we are going to find out map dot get nums i value, and then we are going to add 1 inside it, and we are going to put it out. If this is not the case, if the element is coming for the first time, then what we have to do is we have to go to the else case, and then map dot put nums I, and for the first time if it is coming, the count would be 1. That's all. So we created the map count, and now we are good. Now what we are going to do is we are going to find out the element which has the maximum count. If it is there, if there is more than one element, we are going to keep them inside a list. So for that, let me try to create a list here. So let's say list of, from the above I can directly copy it out, and let's say this is name as L max count element, max count elements. Okay, now what we are going to do is we are going to iterate through the this thing which is key set. Okay, so for that, integer I map dot key set. Okay, so we are going to iterate through the key set, and one by one we'll try to find out the count of each key, and then whichever is the maximum one, we'll try to keep it inside this list. For that, let me try to create a variable. Let's say it is int max count overall, and you can initialize with the minimum value, or I'm just going to put it as a 0 here. So we are good. Now what we are going to do is we are going to iterate through this key set, and we are going to find out the count of each key. Okay, so for that, let me try to create one variable. Let's say max count of that particular key we have to find out. So it would be map dot get that particular key value, and we are going to put it inside the max count variable. Now if max count is greater than overall count, then what we are going to do is we are going to update this max overall count to the max count. So we are going to put this max count inside this max overall count, and then we are going to clear this array, and we are going to keep the new element. Okay, so we are going to add this I, which is the key here. So we are going to add that inside this list here. Okay, so we are going to keep only those elements which has the max count inside this list, and that is what we are doing. Whichever is the maximum one, we are clearing the previous one and then adding that maximum one inside this list. Else, if the max count and the max overall count are equal, that means the both elements, like here you can say for this example, let's say the count of 1 is 2, and we keep the count, we keep that element inside this. Okay, and the max count and the count is 2. Now, if you are going for this element 2, the count for that is also 2. So in this case, the max count and the count is equal. So in that case, what we are going to do is max count. If max count and overall count is equal, then in that case, we are going to put that element as well inside the list. Okay, so just copy this out and then add I here again. So this is the case when we are going to put the maximum count element inside the list, and if there is another element which has the same count, we are also going to put it inside the list. Okay, that's all. Now we have the list ready. Now what we are going to do is we are going to iterate through this list and find out the first and last index of that particular element from this list, and then we are going to find out the difference between them, and whichever is the minimum one, we are going to return that with +1. Okay, so I already explained you why we are going to do +1, because let's say if you are going to find out the difference between this first and last element of this 2, like first and last index of this 2, then it would be 1, right? But the length would be 2. So that is why we are going to append +1 here. So now let me try to create a variable called diff, and you can initialize it with the integer dot, let's say, max value, and it has to find out the minimum one. So now let me try to iterate through this integer I, this list which we have created and which has the all maximum count element. Now what we have to find out? We have to find out the first and last index of particular element. Okay, so we are going to iterate through each element, finding out the first and last index of that element. So here we are going to access this list that we created from this array. Like we have converted this array into the list, and now we are going to find out that particular element from this AL max count elements list into this list, and then we are going to find out its index. So L dot index of I, and now we have the first index, and now we are going to find out the second, or you can say last, which says L dot last index of that particular element. And now you can see why I converted this array into the list, because we can use these methods like index of and last index of and find out its index. Now we have the first and last index of this particular element. Now what we are going to do is we are going to find out their difference, and whichever is the minimum one, we are going to keep it in the diff. Okay, so or you can also make this variable like a mean length and just paste it here. Math dot, we have to find out the mean of this mean length and the difference of them. So last minus first +1. Okay, and we are good. Now whichever is the minimum one, we are going to return it out. So for that, we have this min length. So return that min length. And we are good. Now let me try to run this piece of code and then try to see how it is behaving. So we have this I is already defined. Okay. Sort this subarray and return min length. Cannot find the simple return min length. Okay. So we are going to see. Paint min length. Why it is giving this error? We'll find the index of I and last index of I, and we have this mean length. Copy this out. And what it is? Okay, I think I put this inside this for loop. Okay, so let me try to remove this piece of code from here and keep it out of the for loop. And we are good, I think. Let me try to run it again and then see. So you can see both cases are accepted. Now let me try to submit it out and then wait for a few seconds and then see. So you can see, I think it is taking more time, but yeah, it's a valid solution here. So this is how you can solve this question. So let me try to summarize it out, what we are doing here. So let me try to go to the description, and here you can see we have this array. So the first thing that we are doing is converting this list into the array, and then this array into the list, and then we have a map which is keeping the count of each element. Now we are going to find out those elements which has the max count and keep it inside this list. And then we are going to find out the difference between the last and first index of this element, and then whichever is the minimum one, we are returning it out with the +1. That is what we are going to do, and this is how you can solve this problem. And this is about the video, guys. If you like the video, please hit the like button and please subscribe the channel for more such content. Thanks.